Welcome to 3D Time, from transportation to physics. My name is Ralph Gilman, and this is part 5, Dynamics. Now, there are two ways to look at substance. We can look at substance as something massive or heavy, or we can consider it as something sparse or light, the opposite way. Normally, we would look at density times volume as the mass. But if we turn that upside down and we take a look at sparsity instead of density times the inverse volume, we get the inverse mass. So we're going to define VASS, V-A-S-S, as the inverse of mass. And this will lead to larger values having less mass, but more VASS. Now we can consider momentum. Momentum is the quantity of motion per time. So it's defined as the mass times the velocity, or in symbols, P bold equals mv bold, the velocity, and their P and V are both vectors. So for example, it basically equates a small fast bird with a large slow bird, like a hummingbird or a buzzard, as they have similar quantities of motion. It's a vector, includes direction, and the units would be kilograms times meters per second. We're going to define a new word, fomentum. It's Latin for prop or support, and it's going to be the quantity of motion per distance. So fomentum is going to be defined as the VASS, which is the inverse of mass, times the legerity, which we defined previously. And we'll use the letter Q, boldface Q, equals N for the VASS, and bold U for the legerity. So again, it'll be like a small fast bird versus a large slow bird, but lower numbers are going to equal more motion, a greater quantity of motion. It's a vector, and the units are the inverse kilograms times seconds per meter. Now consider force. The idea is that force causes motion to change. So force is a change of motion in 3D space, pushing to increase the distance traveled, and it's related to the acceleration. Now we're going to define another word, rush, to change the motion in 3D time. So it's pushing to reduce the time, and therefore it's related to expedience. It's like stamping rush on an order, pushing it faster. Let's start looking at Newton's laws. Newton's first law with three-dimensional space. Every body continues in a state of rest or uniform motion unless acted on by a force. Now, the word body here means basically object. A uniform motion is a constant velocity, no change of direction or speed. We haven't defined a force yet, but this is the first law. And it's a kind of a laboratory situation since friction and air resistance are not considered. Now, let's look at Newton's first law with 3D time. I've switched the picture around. So every body continues in a state of rest or uniform motion unless acted on by a rush. So uniform motion is a constant legerity. Could be defined with legerity or velocity. There's no change of direction or pace. And the word rush has not been fully defined yet. Again, it's also a laboratory kind of situation. Now let's look at Newton's second law with 3D space. It states the applied force on a body equals the mass of the body times its acceleration. This is the famous F equals ma law. So we're going to take this as a definition of force. Force is mass times acceleration. You might compare it with the momentum we defined as P equals mv. So force is a vector. It includes direction. Now compare this with Newton's second law with 3D time. The applied rush on a body equals the mass of the body times its expedience. And we're going to use the letter H, boldface, equals N for the inverse of the mass, the vas, and B for the expedience. So we'll take this as a definition of rush. Rush is the vas times the expedience. And we could compare this with the momentum, Q equals N, the vas times the legerity. And this also is a vector, so it includes direction. Newton's third law with 3D space states that to every action there is an equal and opposite reaction. So this says that forces are mutual. And an implication is that equal but opposite forces cancel. Newton's third law with 3D time states that to every action there is an equal and opposite reaction. Basically the same thing. Therefore, rushes, like forces, are also mutual. And equal but opposite rushes will cancel, is another implication. What's the conclusion? Well, we defined mass as the inverse of mass, and then momentum, which is like momentum, and rush, which is like force, and all these are for three-dimensional time. So 3D time is basically a different way of looking at motion. What about gravity, you may ask? Well, that's in part 6, orbits.